This is the tutorial for Chapter 3, Section 1, titled Inequalities and Their Graphs. So let's take a look at our first problem here. And it's asking us to write an inequality that represents the verbal expression. So when I do that, I have to know, first of all, what the inequalities end up looking like. So first of all, I've got a couple different types. I've got this one, and if I'm reading from left to right, so if I read left to right, so I'm reading from this left side to the right side, I would call this greater than. And you really need that verb is in front of it to make sure that we know we're dealing with an inequality. That tells us that we have a sentence in math. And so if we have a line underneath, that means the same thing, is greater than or equal to. So the line represents that it can equal that number or be bigger. And then we have another one, less than. So is less than. So you really got to see that verb is to tell us that we're dealing with a sentence. And then if I have it going the other way, that would be is less than or equal to. Is less than or equal to. Now, there is another phrase that they can use that they typically use with this, because this is very wordy here. And when it's less than or equal to, sometimes they'll say at most, and we'll see that in this tutorial. And if they have this one, greater than or equal to, sometimes they'll say at least. And that's a better phrase rather than this wordy one, is greater than or equal to. So let's take a look at it. It says v is greater than 10. So we just use v, and it's greater than means it's got to open towards the v, because that's the bigger number, greater than 10, and that's it. That's all you're going to do. So b is less than or equal to, so less than or equal to, points towards the b, and to negative 1. The product of g and 2, so g times 2. Now typically, rather than showing it that way, I like to show it this way, 2g. It's less wordy. We have less symbols going on, easier to understand. So g times 2 or 2g is less than or equal to, so less than or equal to 6. That's the way I would write it out. 2 more than k. So whenever I write this, see, it doesn't say 2 is more than, it just says 2 more than. So that means I'm adding 2 to k. So it's going to be like this, k plus 2 is greater than, so is greater than negative 3, and that would be my answer. Now when we're graphing inequalities, we graph them on a number line, and that just helps us understand where the values are a little better rather than just the symbols. So we start with what we have, or the number that kind of is the reference point, negative 2. So I'm going to put negative 2 in the center, and then I just follow what the number line says. Like negative 1 is bigger, and it's to the right. Negative 3 is smaller, and it's to the left. And it's also nice to show, or to think about, to the left are smaller values, smaller, and to the right we have larger values. And so that helps us kind of think about which way to draw the lines to show all the different possible solutions. So as we do this, we've got two different symbols that either mean you're greater than or less than, but not equal. So these don't equal. These are either greater than or less than. So the way we show that is we use an open circle to symbolize that that point is not a solution. So when I draw this, I'm going to draw an open circle on the negative 2. And since y is less, that means it's smaller. Smaller means to the left, and that's the direction we go. Well, let's take a look at this next one. It has a negative 5/3 is less than c. So instead of reading it that way, I like to read the variable first. So I can read it backwards. c is greater than negative 5/3. See, if I was to switch this around, put the c on the left-hand side of the inequality, it would have to match what it shows over here. And how it's open towards the c means c is bigger. So I would say c is greater than negative 5/3, or negative 5/3 is less than c. So now's a chance where we get to use those mixed numbers to understand the number a little better. So this is the same thing as negative 1 2/3, or negative 1.6 repeated. So when I go ahead and graph that, I'm going to start with the negative 1 2/3, and then I'll get a better understanding about where to put the other numbers. So I know negative 1 would be over here, that'd be bigger. And then negative 2, well, it'll be a little closer to the negative 1 2/3. So now I'm going to draw that open circle again, because it doesn't equal that number, but it's every number that's bigger than it, because it says C is greater. So greater means off to the right. So now we have another symbol, and it's the inequality that has the line underneath. It means it equals. So it equals and is either less or greater. And so when it's equal to, that means we're going to end up using a closed circle. Use a closed circle. And the closed circle means that point is a solution. So looking at this one, when I draw it, I'll put 4 in the center here. 5 is the bigger number, 3 is the smaller. And when I draw this one, it's a closed circle, meaning that 4 is a solution, and the values of t are greater than or equal to it. So bigger because it's open towards the t. Where in this situation, it says f is less than or equal to negative 3. Notice I'll read backwards, f less than or equal to negative 3. So when I go ahead and graph it, I'll put the negative 3 here, negative 2 being the bigger number, negative 4 being the smaller. Solid circle again, closed circle, because it equals that number, and its f is less means left, to the smaller values we go. So that's the direction we'll draw it, and let's take a look at the other type of problems we'll see. Over here, we have to write an inequality for each graph. And so now we see the open circle on the 1. So I'll just use x as my unknown in the 1, and you see it's an open circle, so we have no line underneath. But all the values are less than 1. So the way I show that is x is less than 1. Over here it says x and negative 2. Those are my two values. X is the possible numbers. Negative 2 represents the starting point. This time it equals. So we'd have the line underneath, and the values of x are going to the right. So they are greater than or equal to. And over here we have x, again, are the possible numbers. 0 is the starting point, so I'll use that. And the values of x are 1, 2, 3, 4. They're bigger. So it's open to the, it's an open circle because it does not equal 0, and it's all the values that are bigger than. So x is greater than 0. Over here it's a closed circle. So we've got a line underneath it, and since they're going to the left, that means we have smaller numbers. So x is less than or equal to 3. Here it says the school auditorium seated at most 1,200 people. So we have to write an inequality to match. So I'm going to use A for auditorium. And so these are the number of people that can be seated there. At most means less than or equal to. So it can be that amount, but it can't be any more than that. So we have to have just that. And that's another phrase that sometimes you'll hear. So instead of at most, sometimes they'll say no more than. No more than would mean that you can have that amount, but I don't want any more. And so that would be another phrase that can use rather than at most. So this next one says, for a certain swim meet, a competitor must swim faster than 23 seconds. So I'll say velocity must be less than 23 seconds, or the time. How about that? Instead of velocity, not the speed in this case here. We'll say time must be less than 23 seconds. So it can't be 23 seconds because that would equal. It has to be faster than that, so less than 23 seconds to qualify. And it says for a touch typing test, a student must type at least 65 words per minute. So that means that amount or more. So we'll say type greater than or equal to. So that amount or more, 65 words per minute. And just as we could say no more than, so it can't have any more, well, we could say no fewer than for at least. No fewer than. So it could have that amount, but no fewer than those words per minute. So that's another phrase you'll hear, but typically at least and at most are the more common ones for at least greater than or equal to or less than or equal to. So those are the types of problems you'll end up seeing on the homework. Good luck.